Start it again. Yes. Okay, in the last section of this chapter, we are going to look at three things. So that's 2.8. Distance, midpoint, and circle. Let's start with a distance. I have a point A, I have a point B. Somehow I would like to determine this distance. I have coordinates of A as x1 comma y1, and I have the coordinates of B as y2 comma y2. I will form a right triangle. And somehow I would like you to give me these distances. Because if you do give me the measure of the legs, then I will say d squared equals 1 leg squared plus the other leg squared. So leg 1 on the x-axis and leg 2 on the y-axis. But I have to determine the measure of those two. So can anyone give us this distance? Yes. Not over. We're not talking about the slopes. So this is indeed x2 and x1, and this must be x2 minus x1 for sure. This is x2, and this is x1. The difference must be the leg, the measure of the leg. So now what about the y on the y-axis? Right, of course, y2 minus y1. So now I have then the d squared equals x2 minus x1 squared plus y2 minus y1 squared. And this is after we take the square root. Every time we take the square root, we cannot forget something very important. Correct. However, this is a distance. This is one time in which I don't have to put plus or minus. Correct. Excellent. So this is the distance formula. The distance formula. Let's look at the midpoint, and then you give me two ordered pairs to play with this. The midpoint is this point that divides or separates or dissects, if you want, the segment AB into two equal parts. And we can show that the coordinates will be the average of x, the average of y. x1 plus y, x1 plus x2 over 2, and the other one y1 plus y2 over 2. So that was the distance formula and the midpoint, and I'm waiting for you to give us two ordered pairs, any ordered pair, so we can illustrate how we determine the distance between those two and how we determine the coordinates of the midpoint. You said 1 and give us some negatives in there too.
So what about 1, -2?
1, -2.
And then -3, 4.
-3, 4. Excellent. Perfect. So given the two ordered pairs, we're asked to determine the distance between those points and determine the coordinates of the midpoint. Ready? So I will denote them by x1, y1, and x2, y2. I will find the midpoint because that's the easiest. Please add up the two x values and tell me what you get. -2 divided by 2. How much? Good. Please add up the two y values. Divided by 2. That's it. So we are done with the midpoint. We added the two values and we divided by 2. We added the two values and we divided by 2. Now for the distance, I will write a distance formula, x2 minus x1, everything squared, plus y2 minus y1, everything squared. Notice something very important. This is a positive number because it's squared. This is a positive number. And this one is an addition. So I hope I will never see something like this. You understand my point? When I add a positive number, to another positive number, I could never get negative 47. Is that okay? So please make sure you don't write something like that. Okay, so now I just plug in the numbers. My x2 is negative 3, my x1 is 1, my y2 is 4, and y1 is negative 3. What did I do? Hold on, I messed up. Negative 2. So 4 minus negative 2 and negative 3 minus 1. Perfect. So let's do this together, please. How much is negative 3 minus 1?
Negative 4.
But negative 4 squared will be excellent. Plus. Now I have 4 minus negative 2. How much is 4 minus negative 2? 6. How much is 6 squared?
36.
Excellent. So then the distance is the square root of 52. And there is nothing you can do because this is 2 times, oh yeah, 4. Okay. So it's 4 times 13. So yes, we have to write as the square root of 4 times the square root of 13 or to the square root of 13. And that is the distance. Any questions? Do we understand how to determine the distance between 2 points? Do we understand how to determine the midpoint? Yes? Okay, so final topic in chapter 2. I know this is not a circle, but please say it is. The center of the circle, we normally denote it by h comma k, the x and y coordinates. We normally denote the radius by r. Of course, I'm trying to determine the equation of the circle with you. So here's a point anywhere on the circle of coordinates x comma y. Here's my first question. Would you agree that the distance AC is the same thing with the radius? So this is A, this is C, and the distance is the same with the radius. Perfect. Would you agree if I write this as the square root of x2 minus x1 squared plus y2 minus y1 squared equals r? Right? I just use the distance formula between these 2 points. X2 minus x1 everything squared plus y2 minus y1 everything squared equals the radius. This is it, but we normally like to remove the square root. So we will just square both sides and get x minus h everything squared plus y minus k everything squared equals r squared. This is the equation of a circle. Is the circle a function? Of course not. By the vertical line test, it cannot be. It's 2 functions. It's one from above with positive and the one from below with negative. So it's not a function. There are 3 types of problems here, of questions if you want. 3 types of questions. Question number 1. Given, please give me a center and give me a radius. Okay, 2 comma 0, and give me let's say negative 2 comma 0, and give me a radius.
16.
Too big. I cannot graph it.
Okay.
Let's say 2. Yes, it's the same thing. You're right, but I want to also graph it. And we are given the center and the radius, and we are asked, come up with the equation. Write the equation. What will you write? We are given the center, and we are given the radius, and we're asked, write the equation of the circle that has this center and this radius. What will you say?
X minus -2 squared.
Perfect. X plus 2 squared. Awesome. Plus.
Y minus 0.
Very good. Y squared equals? Very good. This is it. This is the equation of the circle with center -2, 0 and the radius 2. And let's say we're asked to graph it. No problem. Here's how we graph the circle. So -2, 0, 1, 2, and the radius of 2, 2 points to the east, 2 units to the north, 2 units to the west, and 2 units south. And that's my circle. And this is the graph of the circle that has the center at -2, 0 and has a radius of 2 units. That's type 1. Any questions? Is this okay, everyone?
Can you explain
Yes, which part?
the how you actually graphed it?
Oh, yes. I plotted the center, which is at -2, 0, and all points on the circle have to be 2 units away from the center because the radius is 2. So, of course, the 4 points are not enough, but I can plot more than 4. So 2 units north, 2 units south, 2 units west, 2 units east. And then I connect them. Second type of problem, we are given x plus 3 squared plus y minus 4 squared equals 9. Question, is this the equation of a circle? It resembles a circle. Very well, right? Let's write the general form. Obviously, it's very clear, right? A perfect square with x plus a perfect square with y and a positive number on the right-hand side. If that's the case, let's identify the center and let's identify the radius. Very good, -3, because you compare these two and you know that h must be -3. Awesome. And k is 4, and the radius is? Well done. Of course we can graph. We plot the center at -3, 4, 1, 2, 3, 1, 2, 3, 4. And now 3 units east, west, north, south. South, north. So this was 3, okay. And 1, 2, 3. Of course, it's not perfect. Well, the last one is why we studied the method a long time ago. And you'll tell me which method. And these ones I cannot make up, I have to copy. On page 332, I mean I can, but it will take a while. 58. X squared plus y squared plus 12x minus 6y minus 4 equals 0. That's the last type, and of course the most difficult one. We're given this equation and we're asked, is this the equation of a circle? And the answer is I have no clue. What I know for sure is that if somehow I manage to present this equation like this, if I manage to present that equation like this, then I'll say yes, it's a circle. But if I can't arrange it like that, I'll say I have no idea. It may not be a circle. So which method am I talking about? A method a long time ago, and I said, will I ever solve using that method? Never, ever, ever, unless you force me to. Because the method is really used for something else. And this is that something else. How is it called? Of course. Exactly. That's what the method is all about. Here. Not solving quadratic equations. But we had to introduce it early, so we know what it is. Fine. Because if you remember, complete the square cannot solve a quadratic equation. We have to use taking square roots after we complete the square. Good. So let's take a look at terms with x. And tell me what they need to complete the square. They need a third term in order to complete the square. What is it?
37.
Exactly. So now this, and this, and this are here. What does that mean? Here where? What?
X.
Of course. Great job. Now this. What is the third term they need? Exactly, thank you. So now this, and this, and this are here. -3. Very good. Let's see what is left and we have not used yet. I have not used this. I have not used this, and I have not used this.
I'm gonna add 4 to
Yes, I have to add 4, and what do I get on the other side? Very good. Is this a circle?
Yes.
Yes, it is. Can anyone identify the center and the radius?
-6.
-6, 3, and the radius is, that's it. This is why I tortured you with that method 3 weeks ago or so. For this. So we don't stumble on that, on completing the square to find the center. Okay, we have roughly about 12 minutes, and I would like you to tell me what you would like me to do. Would you like to practice some more of this? Would like us to choose another problem? Like this one? Okay, perfect. So let's look at something with fractions. 64. So this is x squared plus y squared plus 3x plus 5y plus 9/4. Ugly. I agree. Is this the equation of a circle? No clue. I have no idea. But I know that I have to group this and add something to both sides to complete the square with x. And remember, the middle coefficient is 3, so now we have 3/2 that we square, and this is 9/4. But it happens that I see in there 9/4, which is good. I like it. So I don't have to add anything for this one. Good. So then these 3 are here. Plus what I squared to get that. That's it. So now I'm looking at this and this. So the middle coefficient is 5. 5 divided by 2, and I square, and I get 25/4. I have no choice. I have to add 25 over 4 to both sides. But now this, and this, and this is gone, are here. And 25 over 4 on the other side. It's done. But what do I have here? I have to have y and plus 5/2, indeed. So the radius and the center. Yes, negative 3 over 2. That's it, negative 5 over 2. 5 over 2, indeed. That is it. Any questions? Since we have 10 minutes, I don't want to start something new. I just want to select a couple of problems to work on together. So let's say I will not ask you to find the domain of function composition. But if you find something in my math lab, please bring it to class so we can do it together. Okay. Okay, let's find the domain of the following function. So this is from the review. Problem 80 on page 340. And it's g of x equals the square root of x minus 2 over x minus 5. And then 85 after we finish that, which is f of x, x squared plus 3, and g of x, which is 4x minus 1. And they want us to find f comma g and g comma f. Good. So here we want to find the domain, and here we want to find those two functions. Questions, please. Questions? Can anyone give us the restrictions for the first one? You mean x minus 5 cannot equal 0, and the second one? X minus 2 must be? Very good. So this changes into x greater than or equal to 2, and this changes into x not equal 5. So now what is the domain? Greater than or equal to 2, excluding 5.
Parentheses.
Yes?
2.
You mean bracket 2?
Bracket 2.
Yes? Yes?
Parentheses 5.
Good. Union. Very good. Great job. So now let's look at f comma g and g comma f. Do we all agree with this? Yes, everyone? Okay, so now we want f comma g of x, which is f of g of x, which is f of 4x minus 1. And now you tell me what to do next.
4x minus 1, all that squared.
Excellent.
Plus 3.
Very good. And now when we square binomial, how many terms would you give? We have an agreement from day one. So you cannot say 2.
3.
Yes, perfect. And they are first term squared, 16x squared minus 2 times 4x times 1, 8x plus the second term squared, 1 plus 3. So the answer is 16x squared minus 8x plus 4. Be very careful here. When we square a binomial, we always get a trinomial. And the last one is g comp f. So g comp f of x, right? So g of f of x, which is g of x squared plus 3. And now we stop for a moment and we look at g. And we have to perform the operation that g needs us to perform. So this will be 4, very good, parentheses, x squared plus 3 minus 1. I have to distribute. I get 4x squared, but plus 12 and minus 1 is plus 11.